Ever wondered how your computer knows exactly where to send data on a crowded network? The secret lies in Ethernet frames and MAC addresses. In this video, we'll break down how Ethernet frames work, how switches use MAC addresses to route data, and why understanding this process is crucial for building a fast and reliable network. Whether you're troubleshooting network issues or just curious about how data travels, this is your ultimate guide to mastering Ethernet communication. Ready to demystify networking? Let's dive in.
This is what an Ethernet frame looks like. Data is transmitted over a local Ethernet network through what's called a frame. A frame is a container the data is placed in for transmission. It contains a lot of information. Among the most important fields are the preamble, which consists of 8 bytes and allows the signals to be synchronized between two computers. There's the destination address, where the packet will be sent. The source address is the address of the machine that issued the packet. The type field contains a code that identifies the network layer protocol. The data field contains data from the network layer, from the computer that sent the frame. And the FCS field allows the receiver to check that the packet has been transmitted without error. Now we're going to talk about MAC addresses. Every network device has a unique MAC address. The MAC address is engraved in the network card. It's also called physical address, or BIA, burned-in address, and is expressed in groups of 2 or 4 hexadecimal figures. Hexadecimal is a numbering system with a base of 16. This means that numbers up to 15 can be expressed in one digit. There are 16 hex symbols, and they range from 0 to 9 and from A to F. Each hex digit has a length of 4 bits. As an MAC address has 12 hexadecimal digits, it's 48 bits. The MAC address is made up of 2 parts. The first 24 bits are called the OUI, Organizationally Unique Identifier, and they identify the manufacturer of the card. The last 24 bits are assigned by the supplier. We call this the vendor-assigned portion. In this way, every network card can be uniquely identified. Unlike IP addresses, the MAC address should not be changed unless there's a very specific need to do so. Let's move on to the types of network communication. The 3 most common types are Unicast, broadcast, and multicast. In a unicast communication, the frame is sent from a host and addressed to a specific destination. There's only one transmitter and one receiver. For example, when you make a ping or request a web page, you're only communicating with one machine. This is the type of communication that we see most often in local networks and the internet. Broadcast communication. The frame is sent from one address to all other addresses. In this case, there's only one sender, but the information is sent to all connected machines. And in a multicast communication, the information is sent to a specific group of devices or customers. Unlike broadcast, here customers must be members of the same multicast group to receive information. Now let's look at the path of an Ethernet frame. The switch builds and maintains a table called the MAC table. This is a matching table that links the MAC addresses to the switch ports. The MAC table is stored in the switch's CAM, Content-Addressable memory. The CAM is a type of memory that allows you to do very fast searches. When the switch receives a frame, it will look at the header field that contains the destination MAC address. It will compare this address to the list of addresses on its MAC table, then send the frame to the port belonging to that MAC address. The switch keeps its MAC table up to date, analyzing frames that come from other devices. When a frame arrives, it notes the source MAC address along with the port number it came from. To better understand, we'll see the entire process of a frame. As an example, let's say that PC A wants to communicate with PC B, and that the switch has just been started, which means its MAC table is empty. In the source address field of the frame, we have the MAC address of PC A, and the destination address field will be the MAC address of PC B. First, the switch receives the frame from PC A on its fast Ethernet 01 port. As the switch's MAC table is empty, it takes the opportunity to add the source address of the frame with the port where it received it from. Then the switch checks its table for the MAC address of the destination on the frame it received. As the destination address of PCB is not known from its table, it sends the frame to every port, except the port on which it received the frame. We call this flooding the network to find out who the frame is intended for. The device with the corresponding MAC address, PCB, responds to the switch with a Unicast frame addressed directly to PCA. As this frame crosses the switch, it also takes the opportunity to enter the source MAC address of this frame in its MAC table with the corresponding port number. The destination address of the frame and its associated port can now be found in the MAC table. Now the switch knows that to access the MAC address of PCA, it will have to go through port 01, and to join PCB, it will go through port 03. The switch can now transfer frames between PCA and PCB without flooding the network.